All right, so section 5.1, slope fields. So first, this is kind of its own section in a way, separate from, very different from what we've been doing this semester. So we need some definitions. A differential equation is an equation that contains an unknown function and some of its derivatives. So y is the unknown function, and some of its derivatives like y prime, or there might be a dy dx, or there might be a y double prime, or a d squared y over dx squared, any derivative notation for that function that's in the problem. It's always going to be a y and a y prime or something like that. Excuse me. The order of a differential equation is the order of the highest derivative that occurs in the equation. So if the highest derivative is a second derivative, then it is a second order differential equation. If the highest derivative is a first derivative, then it's a first order differential equation, etc. Okay, we're going to skip that. This is from 2 books ago, so we're going to not do that. A function is called a solution of a differential equation if the equation is satisfied when y equals f of x and its derivatives are substituted into the equation. So go back to Algebra 1. If we were in Algebra 1 and I asked you to check if 2, 1 is a solution to that equation, you would just take the x and y, plug them in, and check and see if the left side equals the right side. Well, that's what we're doing. It's just a little bit more complicated because we're not in Algebra 1 anymore. So first, on the notes, there's a typo, or a printo, or a write-o, or whatever you want to call it. This should be the differential equation that we're dealing with in this example. So I'm given a function, y equals e to the negative t, and I'm given a differential equation. Let me make sure that's right. Yeah, it changed it here. Okay, so I want to substitute for all of the iterations of y, or the variations of y. So I need to find y prime. Hopefully you remember how to do that. It's been a while. Negative e to the negative t. And I need to find y double prime. Did you get it? E to the negative t. And then I'm going to substitute those in. So I'm going to take this y double prime, and I'm going to put it in for the y double prime. Let me make a little line here. E to the negative t plus 2 times, I'm going to take this y prime and put it in for the y prime, plus I'm going to take the y and put it in for the y. And then I just have to simplify that and see, does the left side equal the right side? Well, let's see what we get. E to the negative t minus 2e to the negative t plus e to the negative t. Does that equal 0? Yes, it does. So y equals e to the negative t is a solution to the differential equation that. Okay? Second order differential equation, right? Second degree, highest derivative is second derivative, so it's a second order differential equation. Super easy, right? Okay. So show that every member of the family of functions that is a solution to this differential equation. So what the heck is this family of functions business? C can be any number, and what the C does to that is just stretch it or flatten it out, right? But generally the shape is the same. So this is a family of functions because they have stuff in common, family, right? But there's more than one because C can be any number. So I'm going to do the exact same thing. First I have c e to the x squared over 2. My differential equation, excuse me, I don't know what's going on with my throat. My differential equation is a first order, right? First degree, first derivative is the highest derivative. So I need to find the first derivative. Oh, can you do that? C is just a number it hangs on for the ride. Derivative of e is e. Leave the inside alone, and remember, multiply by the derivative of the inside. Right? Well, this is just 1/2 x squared. Don't overcomplicate this. This is just 1/2 x squared. So this should be like a fraction, but it's too hard to write it as an exponent. So the derivative of 1/2 x squared, right? So y prime is c x e to the x squared over 2. Now I'm going to take that and plug it into the differential equation. So the y prime is going to go in for the y prime equals x times the y. Does the left side equal the right side? Yes. Multiplication is commutative, so I can switch the order of the c and the x, and I get the same thing. So that's good. It says show that, right? It doesn't ask, is it a solution? It says show that it is a solution. So all of this work is the answer. It's kind of like a proof. Okay, and then lastly, slope fields. They look big and scary. Oh, I just dropped a bunch of papers. You probably heard it. They look big and scary, but they're not. Okay, so a slope field. What is a slope field? First of all, it's a field of slopes. Very intuitive there, right? So basically, we'll do some FRQs, I don't know what day. One day soon, where I show you how to make a slope field. But right now, I just want you to be able to identify or match the slope fields. But let me give you an idea of what's going on here. We're given a differential equation. Okay, we have 3 different differential equations in this problem. And to create a slope field, we would make a table of values. So let me just show you here. I would do for I, derivative is x plus y. So I would do like an x and a y and a y prime. And I would literally have to go through every point. So this point is 1/2 comma 0. This point is 1 comma 0. This point is 3/2 comma 0. This point is 2 comma 0, and so on. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. It's probably 9 by 9. So there's 81 points on this graph, if you count how many of these little dash marks there are. So you would make a table with 81 points. Now that's not very realistic, right? On the AP exam, typically they ask for 5 to 8 points. And like I said, we'll do an FRQ that shows you how they identify which 5 points they want. But just to give you an idea, let's just do a couple of these. This point right here is 1/2 comma 0. X is 1/2, y is 0. Plug into the equation, 1/2 plus 0 is 1/2. So you draw a little dash with a slope of 1/2. And of course you're just estimating, right? The next point is 1 comma 0. Plug into the equation the x and the y, 1 plus 0 is 1. Notice that slope is steeper because 1 has a steeper slope than 1/2. Okay? And then just to give you an idea, somewhere else, let's say this point up here, that would be 2 comma 2, right? That very top corner, 2 comma 2. So if I plug in for the x and the y, 2 plus 2 is 4. And that's got the steepest slope of all of them, right? So that would be how you would create a slope field. Let's do just some matching though. Did I just confirm that this matches that? I don't even know. But let's do more than just, we don't want to confirm all 81 points. So let's think about what's going on in the quadrants, okay? In the first quadrant, both x and y are positive. Think about that for a second. Both x and y are positive in the first quadrant. So if we take a positive plus a positive, we're going to get a positive. So all of the slopes in the first quadrant for this guy would need to be positive. And if you look at all of your options, they all have positive slopes, so that doesn't help me. Okay? In the second quadrant, I have negative x and positive y. Well, I don't know which one's larger. Sometimes the x is larger and sometimes the y is larger. So for this function, the second quadrant doesn't help me. But the third quadrant does. I have negative x and negative y. If I add two negatives together, I get a negative. And all of these slopes are negative. Oh, but wait, so are those and so are those. So that doesn't help me either. And then again, I'm going to have the same quadrant in the same problem in the fourth quadrant as I had in the second quadrant. So let's look at a different one. This one, the slope is only dependent on x. So in the first quadrant, all I need to think about is x. X always has a positive slope. These are all positive, right? In the second quadrant, x is always negative. And, oh, look, there's some positive slopes there, so these cannot match. Let's see if these match. First quadrant, again, the slope is only dependent on x in this equation. So I only need to look at the x. So in the first quadrant, all positive slopes, all positive x values, that matches. Second quadrant, negative x values, positive slopes, that does not match. So it looks like A is matching with 2. Not sure if you can see that. You can. Okay. Let's check it. Let's just make sure. Positive slopes, positive x values, negative slopes, negative x values. Third quadrant, I want you to take a second and think about what's going on with the x values and does that match the slopes? In the third quadrant, the x values are all negative and it does match the slopes, right? All of those are negative. And then do the same in the fourth quadrant. Fourth quadrant, x values are all positive and slopes are all positive. So we got that one right. Also, look at the y-axis. That's another strategy. Every point on the y-axis has x equals 0. Make sure you agree with that statement. Every point on the y-axis has x equals 0. And because the slope is equal to x, every slope on the y-axis should be 0, and you can see that it is. Okay? So now let's go with this one. This is another simple one. Now the slope is only dependent on y. Okay? So we used A. Let's see if it works, if this matches B. So the slope is only dependent on the y. In the first quadrant, we have positive slopes and y is positive, so that matches. In the second quadrant, y is still positive, but here we have some negative slopes, so that doesn't match. So it has to be C. Let's just double check it. Positive y values up here, and all of those are positive slopes. Negative y values down here, and all of those are negative slopes. And now this time, we're looking at the x-axis, because on the x-axis, y is 0, right? We haven't gone up or down at all. And you can see, I don't know if you can see it in the picture, but if you look in your book when you get home, the little dashes on here are all 0 slopes, okay? So C matches with 3, which then leaves B must match with I. And like I said, you can check the first quadrant, both x and y are positive and you have positive slopes. Second quadrant, both x and y are negative. A negative plus a negative is a negative, so that matches. And then these quadrants are going to have different slopes because sometimes x will be bigger negative and y smaller positive and vice versa. Okay? And I think that's it. So you have the rest of the period to work on homework, and I will see you tomorrow for your test.